Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 4.7, actually part 1 on piecewise functions. I'm saving part 2 for a more complicated problem, and this will be in a fairly short video, I think. Let's get right into it here. What is a piecewise function? Well, piecewise function is a function defined by two or more equations. Oops, sorry about that. Two or more equations, and then each piece of the function applies to a different part of the domain. So an example would be this. So this whole thing here is considered the whole function, but the first part says that if x, our domain x, if it's less than or equal to 0, then we're going to use this equation. If it's greater than 0, then we'll use the second equation. Okay, well, let's have it at it, and let's see. This function will be repeated on the next page because we're going to use it to answer this question. Evaluate the function above when a, x is 0, and b, x is 4. Okay, well, f of 0, okay, x is 0, equals, well, let's see here. If x is less than or equal to 0, we're going to use the first one. So this is the one we're going to use here. So it's going to be x minus 2. So 0 minus 2 equals negative 2. All right, so f of 0 equals negative 2. The second one, x equals 4. Well, that would fall into the second category here of x's being greater than 0. So f of 4 equals 2 times 4 plus 1. See, I'm substituting into this over here. So that would be 8 plus 1, which is 9. So a value of f when x equals 4 equals 9. So I've evaluated both of those. I've evaluated the same function for two different x values, but each part of the function is different because the value of x is different as defined by this domain up here. Okay, let's take a look at another example. Graphing. Negative x minus 4 if x is less than or equal to 0, and then x if x is greater than or equal to 0. Okay, I think the best way to do this is to kind of graph the entire function first, and then look and see where we're going to keep the graph, and then what part of the graph we're going to get rid of. Okay, so negative x minus 4, I'm going to start at negative 4 here, and then my slope is a negative x, so it's a negative 1 over 1, so it's going to kind of follow this path down here. So this is going to look something like this. But I only want to keep the part where x is less than 0. So it's going to be, here's x is less, here's the x axis. So I'm going to keep the part from here. And more importantly, oops, sorry about that. More importantly, I'm not including 0. So I'm going to have a circle right here, an open circle right here, right? And then x, if x is greater than or equal to 0, well, y equals x is just a line that looks like this, right? But I want to keep the part where x is greater than or equal to 0. So here's x, here's 0. So I only want to keep the part here. And since it's greater than or equal to 0, I'm going to put the big circle there, the closed dot there. So this is the graph of this piecewise function. I'm only keeping the parts as defined by this. I like the idea of graphing the whole thing first, and then keeping the part as defined by the domain, and then getting rid of the other part. Describe the domain and range. Well, the domain here would be all real numbers because the x's extend to the left and to the right in infinitely. And then for my range, my lowest value of the range here is at -4. So my range, y is greater than or equal to -4. All these values up here are greater than -4. Now we're going to write a piecewise function for this graph. Now, writing the function is kind of similar to doing the graphing, but kind of backwards. Okay, so let's take a look at this first section of the graph here. And I know my y-intercept is at 3, so I'm going to put a +3. And it looks like my slope is a -1. So -x plus 3. So I'm going to start with f of x. They're not telling us what it's called, so f of x equals. I'm going to put one of those bracket things like that. It's going to be -x plus 3, semicolon, if x is, are we using if? What are we using here? Yeah, if. If x is, this open circle, if x is less than 0. And then this one, we have a -1 is my y-intercept. And it looks like my slope is up 2 over 1. Up 2 over 1. My slope is a +2. So 2x minus 1, semicolon, if x is greater than or equal to 0. Okay. And again, domain all real numbers. And in this case, the range is also all real numbers because this y value is extending this way. This y value is going up this way. So domain and range, both all real numbers. Okay, well, that's it for now. Nice short video, and I'll see you in class next time. Bye-bye.